the main focus areas of the subject, the theme of the subject. By all accounts, India's top strengths that make it an attractive hub for aerospace industry for global OEMs are strong local talent, a large commercial market, and a high defense spending. Then there is another one that has become a strong draw in recent years, a vast supplier ecosystem built on the rich legacy of India's thriving automotive and space technology industries. The last 1 year and a half, however, has hit the aerospace industry hard. The pandemic has ended more than a decade of uninterrupted growth in 2020. Reports estimate that the size of the global aerospace industry fell from $342.4 billion in 2019 to $296 billion in 2020 at a rate of minus 14%. Please note that the term aerospace industry that we use in this discussion includes all industry activities pertaining to the development, production, maintenance, and support of aircrafts and spacecrafts. Today, we are fortunate to have thought leaders from India's aerospace industry to discuss in depth this topic. Let me introduce our speakers to you. We have Mr. Uma Maheshwar, Chief Consulting Engineer, GE Aviation India. Uma is the Chief Consulting Engineer for GE Aviation India engineering team at Bangalore, which has over 700 team members. The team is involved in design and development of next generation propulsion systems, support of aircraft engine fleet, and development of customized digital and engineering software. Uma has about 29 years of experience in setting up and leading large organizations in engineering, research, and development sector. Uma joined GE Aviation in 2001 and since then has held many leadership positions in aviation engineering. He has played a key role in design and development of 7 new aircraft engine programs covering the full cycle engineering. Prior to GE, Uma held positions with L&T for 8 years. During his association with L&T, Uma led the engineering of 25 mega plants for oil and gas, fertilizer, power, petrochemical, defense, and nuclear sectors involving designing, manufacturing, and commissioning. Uma holds Aerospace MBA from Toulouse Business School, France, and an ME in Mechanical Engineering. Uma has been recognized with many awards and is a member of Global ASME Committee, SAE India Aerospace Board, NAFEMS India Board, NASCOM Engineering, and several other industry and academic bodies. We have Mr. Srinivasan Balasubramanian, CEO of IAMPL. Srini is the CEO of Indian Aerospace Manufacturing Private Limited, a joint venture between Rolls-Royce and Hindustan Aeronautics Limited, or HAL as we popularly call it, in Bangalore. IAMPL manufactures aero engine components for the technologically advanced Trent family of civil aero engines. In his role, Srinivasan collaborates with both Rolls-Royce and HAL to grow the business. Before joining Rolls-Royce, Srini held leadership roles with TE Connectivity Bangalore and was the Chief Operations Officer of Precol Limited and Director's Operations of Lear Corporation India. Srini is an ME, a mechanical engineer with post-graduation in manufacturing management from BITS Pilani and an executive postgraduate diploma in business management from Symbiosis International University. His experience spans across manufacturing, supply chain, procurement, program management, and multi-location plant management. He is passionate about driving digital initiatives in business and firmly believes that digital adoption is the future. We have Mr. Surendra Vaidya, Executive Vice President and Business Head, Godrej Aerospace. Mr. Vaidya has worked with Octoclin L&T before joining Godrej in 1987. He has expertise in welding various alloys to international specifications for oil and gas industries. He set up business in aerospace for Godrej and Boyce Manufacturing Company Limited. Starting with ISRO and DRDO in 1985, now Godrej Aerospace has become one of the trusted suppliers of critical components and assemblies to aerospace brands like Boeing, Airbus, Safran, Eaton, Moog, GE, and Rafale. The team led by Mr. Vaidya at Godrej Aerospace has been awarded by the Aeronautical Society of India for development of cryo-engine technology for ISRO. Under his leadership, Godrej Aerospace has received several accolades and awards. For example, the Award for Excellence in Aerospace Indigenization by CSIATI. Uh, Godrej Aerospace has done a significant contribution and valuable support as an industry partner to meet the target of handing over of BrahMos missile systems in 2007. Other than this, the major accolades and awards include Defense Technology Absorption Award by DRDO, the Best Industry Award from BrahMos, and Mr. Vaidya is BTech Metallurgy from IIT Powai. Now, after the introduction of our eminent speakers, I'll move to the first question of our panel discussion about the current scenario of the aerospace industry globally and that of India, especially from the perspective of the last 2 3 years, which have been really hard for the industry. Gentlemen, my question is that how has it impacted the industry, especially from the supplier and the human resources sides? How do you see this challenge impacting the mid to long term plans of major OEMs like Boeing and Airbus? We'll start the discussion with Sini. Sini, over to you.
Thanks, Tom. It's a timely question. I mean, we are experiencing that for the last at least 6 9 months. I mean, there's a kind of recovery that's trying to happen, though in the last few weeks with the Omicron coming up, there's a kind of a different thinking. But we are positive now and then looking forward for the industry to get up and get back to speed. I mean, when that's happening, I mean, when the industry is recovering and getting back to speed, there are, as you rightly pointed out, there are issues coming up in the supply chain area and in the people related, I mean, people area. There are, because of the muted last year and a half, there were always apprehensions from the people side, whether, there are two thinking. One is the youngsters, particularly, I'm not talking about seasoned professionals, the youngsters, they were thinking and then making choices available in front of them to switch over the industry, from aerospace, aviation to some other industry, because, they were worried, about the longevity of the impact to the aviation industry. As we all know, this is one of the industry which was heavily impacted. So there's a kind of an attrition due to people making choices of the industry from the younger, the millennial generation. And the next one, from the supply chain side, there is still, we continue to experience some kind of a logistics and supply chain issues due to issues starting from the availability of container for the sea freight and availability of flights. It's all getting expensive. So we face challenges in the supply chain side as well. So, we are experiencing that, and personally, we are experiencing this in our business. So to mitigate that, we know that this is nothing, but it's not a new problem, to just tell you. This is a kind of a problem we had pre-pandemic also, in a different, that the reason for that was different. It was always, the industry was growing continuously. And when it was growing, people, they were also very aspirational. And that was the time, we had to manage it differently. Now the situation today is little, the root cause is little different. So we'll have to, how do we manage that, and how are we managing that from our side? That's what I want to just talk about a couple of things here. One is about, irrespective of the problem, whether it is from the supplier side or from the people side, we have to keep the customer focus, intact. That should not change. Whatever we do, that should, finally we'll have to give a great experience to the customer and make them to believe that, as a partners to the industry, we can rise to the occasion and then continue to supply. That's the first, that should be the driving point for whatever actions we take in the downstream. Coming to the people side, definitely one thing what we stick to the basic is like kind of respect the employee for their expertise and contribution. When an employee, normally it happens like when people think that industry is not respecting them, or the company is not respecting them, or their relationship with their manager is, it's not respectful. That is when they try to make choices. And that is where we put the fundamental thing in place, like, respect each employee for their expertise, and also, treat them with dignity and respect, irrespective of any situation. That is very, very important. And in the process, with the changing scenario, there is, I'll also come to that point, because there is a changing scenario in terms of customer expectation, in current situation. because they also expect whenever they want the product, they want delivery. Also, that there are new deals are happening at a higher, highly cost competitive levels. So the way to manage is like people. How do we utilize the people better? And here comes, we can actually provide a single solution for two problems. One is people leaving us, another customer expectation. So what we did is like upskilling and multi-skilling of people. That is very, very important. That is particularly, it's also liked by the people when they are they are multi-skilled, they are upskilled by the company, spending money for them. So that's something which we started and it's going on, and that has given us good results. With that, and also we keep talking to people about the future plans, engage with them. Like how do we? I keep telling our guys like engage with our customers better than before. When they are when all of us are in trouble, and particularly when customer things are very dynamic, it's better to get engaged with them continuously than before or than ever. Same thing we'll have to do with our employees also. And when we do that, and we are able to kind of retain them. And apart from that, we also put in place some retention policies which takes care of their aspiration for the future and provides them confidence. And coming into the supplier side, there is a lot of disturbance in the supply chain. You can some of the supply chain lead time in the industry is very, very long. It can lead to starting from a year to a couple of years to recover. So this is something somewhere we'll have to close engagement with our customer to understand their plans and translate that into a kind of supply plan and engage with the suppliers also better than before. It's applicable to engagement with the suppliers also better than before, and continuously work with them. And the biggest another doubt expressed by the suppliers is on the credit side. If in case there are a lot of we know that there are a lot of financial impact, and even some of the companies are facing financial strain in their balance sheet and looking for support. This is where, of course, I will not talk about that much, but the banks or the financial system of the country came into play, and a lot of good things also happened. Helping hands were provided to the industry itself by the government as much as possible. So coming to the technical or the business management side of it, we'll have to give confidence to the supplier and establish the trust with them. That whatever numbers we are talking this time, because there's a lack of trust over the last year and a half about the numbers, whatever demand numbers, whatever we project to them. There is a kind of a feeling that we are telling them for the sake of keeping the morale high, not in the reality, like in terms of generating cash. So that's something which we'll have to bring back the trust into the suppliers, which we have done our best in terms of collaborating with them, and then giving the right realistic demand and picking the parts from them as per the commitment. And more importantly, that confidence is a process. It is not that just by mere words it's not going to help. We'll have to have we have a process in place in our system. Of course, everybody has that process in place. So we do the weekly, fortnightly, monthly, and sometimes daily reviews with respect to based on the criticality of the supplier and the parts supplied by them. So that engagement is happening. And second, and the most important thing is we'll have to show them that we are also investing in our future. When they understand that, then they believe that, we are investing in the future, so there must be something in future. That's why these guys are investing. So that we are trying to connect the digital. Our first priority today is how do we digitize? The productivity is, during these difficult times, productivity is very, very important, because the cost, there is no option for increasing or changing the cost profile. We'll have to take this as an opportunity. We have taken this as an opportunity to restructure our cost and to come at the best competitive levels. But having said that, when the demand is going up, we should not add the resources in terms of capacity, people, or material, and should not lose that advantage whatever we have built over the crisis. We should not allow that to go waste. So we are kind of trying to, when the demand goes up, we'll have to just see like how do we manage. And one of the tools what we are adopting is the digital tools, and we are working with various people and also developing some of the tools inside to make that productivity and give confidence to both the downstream and the upstream. So with all this happening, and then we are at the moment in a position to cope up the changing scenario, and confident that this is going to help us to emerge as a better industry are a better company than before after this crisis.
Thanks so much, Sini, for that very comprehensive perspective and setting the tone for the discussion today. I'll take that thread onward to Mr. Vaidya. Mr. Vaidya, uh, uh, see, obviously, it's been about 2 years into the crisis, and we are still not out of the woods. But I believe aerospace, being the hardest hit industry of all, among all, must have learned some lessons and must have grown more resilient. Civil aviation is picking up, as Sini said. What is the overall scenario? Can you take us through the crisis that happened, the impact on the industry, the lessons that this industry has learned, and how it has been able to cope up with this situation?
Yeah, so thank you so much, Mr. Anand, and it was really my pleasure to be with you in this particular virtual meet, and especially at the time when we see that the pandemic effect is slowly slowing down, and we see that the growth is going to take place in the near future. So if I just put it between 17 to 18, I mean, before the pandemic, the aerospace had really a golden era. Everybody was really ramping up the production, including Airbus, Boeing, all the engine manufacturers like Rolls-Royce, GE, Pratt & Whitney, Safran. And suddenly this pandemic came up in the period, say, if you see every business is kind of a sinusoidal curve, but when you are on the ramp up of a sinusoidal curve and suddenly you come from the positive side to the negative side, it really makes a huge impact on all your long-term and short-term plans what you made, because when you see there is a growth, obviously industry come forward with a lot of investments, recruitment, technology, acquisitions, and suddenly you have to apply a brake to it. It becomes a little difficult. But I think this is the right time where we should really think that in the lean time, really we should think how to become lean, because I think important point for Indian manufacturing industry is that even though technically we are very, very competent, thanks to ISRO, DRDO, who started this initiative maybe 4 decades back, and slowly got the private industries as well as the PSUs into this fold. But since we never had opportunity to produce in numbers, the aerospace manufacturing per se in India is never a competitive. We have always really struggled a lot to meet the international prices, and probably even on the delivery fronts also, because we are never produced in numbers. Unlike the auto industry, who got advantage of becoming the, I mean, first as a suppliers to the famous Maruti Suzuki, the entire supply chain and complete revamp which happened in the Indian auto industry. And then many others like Tatas and Mahindras who came forward with their beautiful designs, and they developed their own supply chain. And slowly then we got a confidence and we became the OEMs, or we became the supply chain partners to most of the global OEMs. And today Indian auto industry is being respected for both, I mean, for quality and for their delivery. And they could do this because of very good systems. Now, AS 9100 brings as a mandatory requirement for every aerospace industry to have a system. So as far as the systems are concerned, I don't think any Indian company is falling short of the requirements as compared to the rest of the world. But as I said, we are surely finding difficult. And you also asked a very valid question to our panel colleague Shini on the supply chain. And unfortunately in India, the supply chain, as far as the raw materials bought out, which are very essential and requires a special approvals from the OEMs and acceptance or the adherence to certain standards which are internationally being used. There are hardly any such kind of suppliers or supply chain partners in India. So we are heavily dependent on everything to be imported. All our inputs for our manufacturing are imported either from Europe, US, sometimes in China also. And now the Japan and Korea is also coming up, and they are getting into it. Now, what happens is during this lull period, even though we get a huge time to really work on these lean principles, or we have really taken in the last 2 years a lot of initiatives on our IoT, on our digitization, on our automation, on various studies which we were delaying it because we were ramping up our productions, and during the ramp up, you cannot really do your R&D on the technologies and what are the new things what we should really bring in. So we could get all those times in the last 2 years. But on the same side, the retention of skill becomes the most important. I mean, one is financially, how do we really retain them and keep getting them? But if this is a very specialized field, the aerospace is not something which you can really acquire very easily. But once you acquire, and if you don't practice it, for example, a machinist or a welder or for an inspector, if it doesn't do that activity on a daily basis, it is likely that he will lose his skills, even though you can retain him by paying him his salary or giving him whatever increments or other things he's looking in this pandemic time. But how do we retain his skill? So they all were worried and they were all really looking for opportunities to come in. So we had to issue the dummy orders and produce it even if it is not required, and keep their skills intact or give them some mock-ups to keep their hands completely trained onto it. So that was our first challenge what we had. Second, all of these assets what we use, they are very, very specific assets, very highly sophisticated machining centers, welding centers, robots. Now, those also require servicing and usage, because any electronic item, if you don't use it, and most of the assets nowadays have become electronic rather than the conventional. And those controllers, even though you will keep the ACs on, humidifiers on, but they must be run. If you run them, then only you can maintain it. If you don't move slides, the slides will get rusty. If you don't move the slides, the dust will get accumulated. The slides will get eroded in a particular region. So the entire spectrum of the machines or the assets have to be really run for. And that also is another expense. I mean, running these assets just for nothing. Sometimes we have even run the assets even in the air cutting kind of a cycles, and there was no actual hardware to be cut. Fortunately to us, and especially for Godrej and most of us who are involved into a good product mix, like we are into the missiles, we are into bombs, we are into the space, we are into the civil, and we are also into the military aviation. So the offset orders what we had, that kept us alive, because that has nothing to do with the civil aviation, and thanks to our friendly neighbors who really encourage us to invest and really expand. And in this pandemic time, we saw what happened to our northeast and what is happening on our north side, our east side, west side, and surprisingly to our south side also, where we used to have a lot of comfort. But I think the Indian Ocean, Arabian Sea, everywhere there is a distress today. And that really puts in a lot of effort by Government of India through the MOD to bring in many projects on fast track. And fungibility of some of the assets or operators may not be that good. But the team really took it very positively, and they really moved from our civil aviation export, what we are doing, which has come down, as you also pointed out, roughly 30%. I mean, what we are doing, today we are producing only 30% and hope to ramp up in next 2 years to 60%, and then probably 24, 25, we should be coming to the pre-COVID conditions. That's the predictions what we have. So this good product mix helped us. The last point I would like to just bring it here. You asked specifically about how the Airbus and the Boeings and the others are trying to cope up. I think among all of them, the Boeing got probably the maximum hit. One is the impact of the COVID, of course, which brought down the numbers. But they had also a challenge in the MAX, the 737 MAX, which had 2 unfortunate incidences. And that put the restriction on usage of that, and the Federal Aviation Authority was not giving them permission to build those aircrafts in the US. And the supply chain of the entire Boeing on 737, and that also impacted on their other aircrafts, has impacted a lot of the Indian industries who are on the Boeing and Boeing supply chain. Now, it's very difficult for us to revamp all those numbers, as well as for Boeing, it will be difficult. And last is surely we are very, very watchful and looking at what is going to happen in next 2-3 years. The lean period, which has been forced on all the aerospace industry, is giving actually a lot of breathing time to the Mitsubishi regional jet, it is giving breathing time to the Chinese regional jet, it is giving to the Bombardier regional jet, the Russian regional jet. And India also is thinking of restarting our Saras from 14-seater to 19-seater. And we are also trying to make the Dorniers to have the linkage of all our districts to the metros and metros then connecting to the international sites. So I think we should be watchful. It is not going to be dominant in aerospace with the Airbus and Boeing, which were dominating instead of monopoly, that the duopoly, what we were saying. I think there will be a number of more players going to emerge as we come out of this COVID and the market picks up. So it's geopolitical situations are really, really dynamic. One has to be very alert on these situations, and we should really look for it. So thank you. I will stop it here. Allowing my colleagues to also share and participate on this.
Thank you, Mr. Vaidya, for those amazing insights. You touched so many points in your perspective, informing our readers. Uma, Mr. Vaidya and Sini, they have touched so many points and so much in depth. What is your perspective to add to their thoughts?
Yeah, so Anand, let me put the whole theme of your session in front of us. You know, what's the role of Indian aerospace industry in the growth of the country, right? I think it is a tremendous opportunity. And I wanted to take a little macro view, and then I will share some specific thoughts. So let's look at three things. No question, the pandemic has posed an unprecedented crisis and challenge in front of the entire aerospace industry. We are still sailing through, but every indication shows, including Omicron and all the variants that we might see in the future, that aviation industry is going to witness unprecedented growth globally. So that's given. It's a reality. It is not about whether it will happen. It's the question when it will happen, and when can be delayed by 2-3 years. But it is the writing on the wall is very clear. The industry is going to grow, and India as a country is already the fastest growing aviation market, both from commercial aviation and also from military aviation. So we are really at that threshold of that movement. We have already started a journey, and we are going to see unprecedented growth. I am not undermining the challenges, the tactical challenges for survival in the next 2-3 years. But that being said, let's look at the glorious opportunities that we have. And I also wanted to share, we happen to be at a time when the entire aviation industry is going through unprecedented technological challenges. So the key theme for the future is sustainability. The entire aviation industry is going to evolve around sustainability, including sustainable supply chain, and it is going to displace some of the existing players. Today, we have some countries and some companies which are known for expertise in aerospace manufacturing, but if they don't adopt sustainable supply chain concepts, they will be displaced, because that's the theme for all industries, particularly for aviation industry. So that's a second disruption. The third thing is around digital, particularly Industry 4.0. Any country, any company which can adopt the Industry 4.0, in my opinion, would be the leader. And Industry 4.0 has such a magical change in the entire supply chain case, because it is all about integration, not about excellence in one particular company. So how can we integrate different activities and drive more cost, more predictability, better quality, safety, etc., are the most important things. So digital, we talked about industry in the digital Industry 4.0, the sustainability. And then finally, I wanted to say, from a technology standpoint, aviation is going for more sustainable solutions like electrification. Can we reimagine the flight? The future of aircraft will be different. So we are looking at hybrid electric propulsion systems, using hydrogen as for combustion, or sustainable aviation fuel. So there are a lot of new disruptions. So we are going to see in 20-30 years, the whole flight the entire industry is going to see. So if you look at these macro trends, we suddenly realize that it is, probably an opportunity in a century that India is going to see. The whole aviation industry is going to see, apart from challenges, but it is a great opportunity. I think there is no country which is well placed to not just adopt, but also lead in this revolution. Because one, we have a huge domestic market. Second, we have young talent, which is digitally savvy. So the future is all around digital. The third is around sustainable supply chain. We have not really invested much in supply chain. I mean, we have some established companies, but if we really have to be the leaders for the future of aviation, then we have to really set up this sustainable, the most modern digital plants, manufacturing plants for the future. Can India be the future factory for the future of aviation? So these are really the opportunities, and I think we are well placed. So that being said, in the next few years, we're already seeing a growing demand for supply chain. Practically last 2 years, most of the vendors were bankrupt and they had huge disruption in the operation. So how do we revive? Because we are going to see more demand for aircraft and engines and rest of the aviation industry. So there are already initiatives from OEMs to ramp up production. So it's not easy to stop operations and restart and really make record production of these parts. So that's one. It's very clear that we would need much more engines, much more aircraft than what we would have forecasted, because again the growth is more than what we predicted. The second thing is around this whole particularly for Indian manufacturers. I want to encourage really putting some money for R&D because it's a different game as compared to automobile industry or any other industry. See, you can design an automobile for India, and it's pretty much for your road conditions and your comfort and for the price point that you want. But aviation industry is different. You can't design an engine or an aircraft for India, unless you really have such a huge demand domestically. But ultimately, we will be competing on the global era, right? So we need to think of, how do we really build global supply chains, global products, global technologies? So it needs a very different approach, particularly investing in R&D and being patient, and also seeing from a long-term perspective rather than thinking of short-term. I know short-term is important because we have to survive and we have to show, money to our shareholders, stakeholders. But then please do leverage the government schemes, invest in some technology, being more smarter, more digital, more automation. And then finally, on the human resources, we need to really step up our manufacturing capability. We still have huge gaps. If I take a jet engine, maybe in our country, we can manufacture, if we have full freedom, we can manufacture maybe 30% of the modern jet engine. We still can't, manufacture 70% of the engine because we never dealt with those materials. We never dealt with those kind of complexities. Things like additive manufacturing can be a disruptor. So the point I'm making is we are going to witness unprecedented growth. Aviation will be the growth engine for Indian economy and for the rest of the world. And if we can make best use of modern technologies, India can be the factory for the future of aviation. And then we can be the leaders in developing world-class products and world-class technologies.
Thanks, Uma, for that comprehensive thought. I'll take this discussion forward to global value chains. Now, India mostly, as our esteemed speakers pointed out, has a lot of potential. But from the data, from the present scenario, it is evident that we are operating in a supplier space, which is mostly tier 3, tier 2 supplier space when it comes to global OEMs. Now, my question to the panelists is, and I'll start with Sini, that how and in what ways can India as a whole, as an industry, as an aerospace industry, move up the global value chain of aerospace?
Thanks, Anand. That's another good question. The situation in which we are all working on. The interesting situation is we have a lot of advantages to go up in the value chain. The number one is like the engineering talent or the engineering design centers in India on the aerospace side. Or aerospace, what I mean is like including the defense and the space side is humongous. There are a lot of engineering talent available and they are getting used to it. And to go up the value chain, another thing what naturally helps us is the changing technology. As Mr. Uma pointed out a few minutes back, the kind of the sustainability needs of the future. It is shifting the technology to the new levels, starting from whether it's a hydrogen fuel or whether it's going to be the electric engine. There is a lot of new engineering requirements that is going to evolve in the coming years. So this is an opportunity where we can be a part of the new value add, which is no need to. There is always a conflict when you are trying to invent the things which are already invented. The engine per se currently, what is the next level of value add we are going to provide from India when there is already an established engine or established structures available. It's only we are not going to invent anything new. But we are trying to solve a problem which is already solved in terms of providing some competitive advantage in terms of cost or delivery. But per se the solution is already available. But to go up in the value chain today, the best opportunity available in front of us is to use our engineering skill strength to the evolving technology, which are of sustainable nature, in terms of electric or hydrogen fuel. So that's something which it's going to happen, and there will be a lot of efforts happening from our side. There will be a lot of, definitely it's going to happen in a fast track with the kind of the commitments made by the global, the countries, per se on the COP26. So it's going to drive the sustainability requirements to a new level. So which means it's going to provide a lot of opportunities both on the design side, and next one, it's also going to provide a lot of opportunity on the component manufacturing side also. We can, as a country, we are tropical, and then we are for sustainable manufacturing. If we put our thoughts together, we have a roadmap. Per se, we have a roadmap up to 2030, 2040, and how are we going to evolve our sustainability thinking in the coming period. How fast we can go net zero. So that's throwing a lot of opportunity, and probably we realize that we can be faster than what we thought probably a couple of years back. Today, with the situation evolving and with the kind of alternate energy options available in front of us, starting from solar or the fuel cells or the other options available with the technology, the evolving technology, we are better placed in that area to become a component manufacturers with sustainable technology. That is going to be very attractive for the OEs around the world. We can compete with the developed country vendors faster in this, taking this as a new data, new baseline. So this is going to throw a lot of opportunities. Having said that, even in the existing situation, what naturally happens is there is a lot of current situation when the industry is evolving today. They are faced with challenges. It's not going to be demand is coming back and only put the capacity and it's going to happen. No, when the situation is coming back today, it is coming with mixed bag of challenges. The customer taste is changing today. For example, the commercial airline industry, it's going to operate differently. It is at least for the initial period, it's going to depend on the leisure travel more than the business travel, because business travel, it's going to take some time. As our research says, it's going to people are adapted to the new method of working. But so it's going to, particularly the long distance travel is going to depend on the leisure travel. When the leisure travel is, that is what we are going to depend on. There is also sensitivity to do that, because the long haul wide body engines, when they are wide body aircrafts, when they have to depend on the leisure travelers preferences are different in terms of they are willing to break the journey and take another flight for cost reasons. So they have to rearrange the cabin seating to everything. They have to think differently. and think in a way that how they can attract the leisure travel or promote leisure travel better and better. But finally, it's going to be a new thinking that is supposed to evolve. In this period, how can they do that, but in a cost-effective way? That is where the digital, starting from there, the digital is an option available to attract the leisure travel better, and how to give the options. That is possible. That is not going to be possible with the conventional method, but that's going to be possible only through the digital progress, whatever digital imagination that is going to happen or be possible with already some of the airlines are trying to adapt that. So starting from there, how we can provide value addition in terms of providing the digital support. India has inherent capability on the technology side. So I mean, we have a better, with our skilled workforce available in the digital side, we can be the supplier of the new evolving digital platform requirement and support that for the airlines industry much better and faster. So that is going to be another opportunity to go up in the value chain. So, and the next one where along with when these two things are happening, more so we'll have to increase or kind of improve our research and development investments, and also the testing, investments in the testing, which is going to be a requirement to prove trust to the global OEs, particularly kind of Boeing or Airbus. And when we have the complete capability within India to be considered as a value service provider, the R&D and the testing capability is a must, going forward. And if that is going to be possible within our own country, available at an affordable, affordable rates, affordable competitive pricing and delivery levels, and then there is no going back. It's going to happen. So that's my view on that.
Thank you, Sini. I have a quick follow-up question that I'll put forth to you as well as other speakers. See, technology and particularly research and development in technology is is the sweet spot that all economies want to hit. India acquires a particular space down the value chain where it is into components and co-creation with biggest brand. You are heading a company that is co-creating products in collaboration with one of the biggest names in aerospace engineering, which is Rolls-Royce. So your company combines the legacy of HAL with the technology prowess of a global leading company in engineering. And that's a great example. So India is at a place where it has to really catch up and catch up fast if it has to take the advantage of the potential that Uma pointed out in the coming years, and especially the domestic civil aviation industry. Defense industry takes a long-term horizon. It takes decades before one is able to capitalize on the growth of the defense spending. But civil aviation wise, it's amazing. The growth had stalled in the last recent years, and particularly during the pandemic. But I myself was amazed. I went to my native place, and it's a very small place tucked in the foothill of Himalayas. And there's a new, airport that has come up. And the people who could not even afford railway reservation or railway berth a few years ago, they were there with their families and lots of luggage, all sorts of things, and all sorts of edibles, eatables. It was such a great sight to behold, and obviously the smells of my village. So the civil aviation is really going to take off, as Uma pointed out. Now, in order to capitalize on this, the domestic market, the global market, where the drones and the autonomous vehicles are coming up in the aerospace sector, India has to really go up the value chain fast and take a bigger slice of the pie. That can happen through research and development and technology. So a follow-up question to this long-winded question, which I had for the speakers for a long time: how can we increase the R&D activity in India, whether it could be in collaboration with the public sector, with the government, or with international technology companies? Over to you.
It's a mixed answer. Like, it is collaboration between both the private and the government. That is what will make this happen. And finally, when the international companies are going to put their money in India, they also need return, and which is going to come from either the market which is there in India, for the market the new technology is required, yeah, and it's going to provide them return in terms of the consumption or the travel that's going to happen in India, like whatever you said, like, that's what will attract them. While that is happening, like kind of, the civil aviation is in India is working on a lot of new airports. Before 2040, we are talking about another 100 new airports. And also, there are a lot of tier 2 cities are connected with the UDAN scheme. And while all these things are encouraging from the demand creation side, on the technology side, it is, the technology has to, that who can give the technology, but how do we make it India as an attractive destination for the investors to put their money and make them feel safe that it is going to provide them returns. That is where the trick is, and that is where the policymakers and other stakeholders have to work together and understand the final benefit that's going to happen to both the investors and as a country, and do the necessary support to move the things forward and faster. So
Thank you.
from a country perspective, I think it's the first step has to be taken by the policymakers to create that call to the investors.
Thank you. Thank you, Srini. Mr. Vaidya?
Yeah, so I think you started with why India is at a tier 3 level so far, and with more than 3 decades or 4 decades of experience in working with aerospace and defense. I think it's a chicken and egg story. Whether you prove to the world that we can really make larger systems or systems where we have full control within us, or are you going to bring the technology from outside and always be under the license production or under the TOT where they tell you only know how, but no, they don't tell you know why. So I think the most fundamental question what the R&D institutes, ISRO, DRDO, Aeronautical Development Agency, NAL, and all those who are in this area, they should really answer is that have they really made not only manufacturing built to print outside, but have they tried to develop more and more industries who understand beyond manufacturing? I mean, today when the drawing is given to us and we have been asked to produce component as per the drawing, our focus is how do we produce that component to its perfection and at the cheapest cost so that we can deliver on time and make money out of it. But we never really get involved into it and find out why this particular material is chosen, why these tolerances are being asked, why this testing is being asked to do at certain G levels and certain vibration levels and shocks and bumps and so many other climatic conditions in which it is going. So I think even a manufacturing engineer also must have a greater understanding of why this particular component made out of this particular alloy and this particular way of manufacturing, and certain processes are allowed and certain processes are not allowed. And if you have to change, what kind of approvals are required and why it is costly to test and retest these components if you are going to come out with newer technologies. So if we have to cut this, the vicious circle, I think the government of India has in the recent past taken some 2-3 good decisions, which I would like to mention it here. One is banning of these 209 items and another 200 items, which they would like to ban it in early 2022, allowing and forcing Indian industry to really take over this aspect and take a mastery of how to assemble, integrate, and not only assemble, integrate, but we have never tested how to maintain these assets for the next 10 years or 20 years of its life. We are only producing articles today, mainly or in the last, till the last 5 years, articles which will be only for R&D for the designers use, or at the most the users trials, but we never produced it. Like the second major decision what government of India took finally is to produce those 85 LCAs within the country. It's a fantastic decision. Now we know not only how to develop it, but how to really create an entire ecosystem. Because for HAL to produce 1, 2, 3, 5 or under TOT was a different than now it is your baby and you are going to create this aircraft and you are going to support it for the next 15, 20 years. And we want exactly the same level of service as we are getting it from the other OEMs. That kind of a benchmark when the government has asked them, I think it has really opened everybody's eyes that now what we are talking is much beyond what we were doing in the last 30, 40 years. And now how to really compete with the international market. Now, obviously, we discussed in the first our session about the supply chain, but I would like to extend the supply chain not only from raw materials and bought outs, but to the various facilities, tools, jigs, fixtures, expertise in making it to the latest technologies, using various services like surface treatment, heat treatment, non-destructive testing, MRO, what is going to be required, whether it is a military aircraft or a civil aircraft. A huge MRO facility is required where we'll be maintaining, repairing, overhauling these assets. Now, this will all be required to be shared because these are very, very, very expensive facilities, what I am talking about. And ISRO and DRDO fortunately have developed all these facilities. And that's another very important decision government of India has taken, that any laboratory, any facility which is created either under Department of Science and Technology or MOD or with Department of Space, they are all now available for private industries to use. So now we don't have to really invest. It's a question of only paying on hourly basis what they will charge. And government is very fair. They are now going to charge only the operating cost and not the cost of capital what they have invested. So this is going to really bring us competitive. Otherwise, we were able to produce. I differ little with the Uma, even though his assessment will be far better than me. But just for argument's sake, sorry, Uma, but I would like to contradict and say that I think only 30% we cannot produce in India today. 70% of the aircraft, surely all the Indian manufacturers put together will be able to produce it. It's a question of whether we are willing to form a consortium, a cluster, or come together. Independently, your assessment is 100% right. But if I had to talk, Indian industry put together and with ISRO and DRDO, whatever work they have done in their own things with all the PSUs like HAL, I think more than 70% of the technologies and the 70% of the manufacturing facilities and capabilities are available. Now, what is not available is really the exotic alloys and that like single crystal braids and other not the rotary friction, but the linear friction technologies, the 3D printings, the ceramic technologies which are required, special coatings which are required on this. So these may be some areas where, once again, if we come together and form a cluster and really not compete with each other, I am sure that in the next 3 to 5 years, even the balance 30% also will be able to do it. I'm not too sure. I'm not from the electronic industry, so I cannot comment how far, because having only a good engine or having only a good aircraft is not going to be sufficient mechanically unless it is backed up with a good avionics or a control systems, fuel management systems for the engines. We will not be able to do it. So pardon me for my ignorance on the electronic side, which I cannot confidently say like I could say for the mechanical systems. And the last but not the least important is, I think, the only thing what I will really demand from government of India today is they should really strengthen our DGCA, DGA, QA, and the CEMILAC. If we produce a part and if we cannot get the right kind of a certification and we have to be dependent on the certification to come from outside, I think that is the biggest crime what will do it. And sorry to say, but our rating with DGCA or our other certification agencies worldwide is not that high. They will be maybe in the first 10% and not really the top 10 or something like that, the bottom 10 rather. So this is something which we should really work together and improve. Then we will be easily move up from supply chain level 3 to maybe 2 and 1, and you will see many OEMs happening in India in the near future.
Thank you, sir, for your candor and for your incisive thoughts, which is very much the need of the hour. I'll pass on the baton to Uma. Your thoughts?
So I think Mr. Vaidya's point, I fully agree in terms of the spirit. Definitely, we have tremendous opportunities, and that was the reason why Mr. Vaidya could recollect, if he could recollect, 18 years ago, we had no company who had worked with any foreign manufacturer in making a jet engine part, and Godrej happens to be the first company where they actually made the first complex part for a jet engine for GE. So we are extremely privileged to have Godrej as that first company, and I'm 100% confident that with more collaboration we could do more. My point was in terms of the price competitiveness when you look at the ecosystem. So coming to your question, Anand, I think the question in front of us is when we look at Tier 2, Tier 3, even beyond, right? It's about the trend is a supply chain ecosystem competing with another supply chain ecosystem. It's not really about a company competing with another company. It's really the ecosystem's competition. So, which brings to the next question is, do we have the supply chain ecosystem which can make these Tier 2, Tier 3 companies globally competitive? The answer is no. And there's a golden standard, well-established success mantra all across the globe, which is really about the 4 pillars of the supply chain success, which involves private companies, the public enterprises like HALs, then government, and then academia. These 4 parties have to come together and create that supply chain ecosystem. And we see many gaps. If I analyze the supply chain of aviation, of an aircraft, for example, we have started some capability around the aircraft structures. We have Mahindras and Tatas, getting into this. Then when we look at composites, we have technology, but we have not industrialized to an extent where we could compete with established global players. And remember, the puzzle that we are solving here is there are already companies from last 70, 80 years, even beyond, who have been there in aviation industry. They have been investing in R&D and people and resources, and they are known for certain core competencies. And they have brought the cost to a point where it is very tough to break that point or that jinx. And they have been known for the quality, and in many cases, they are monopolies, right? So that's the way the supply chain has been evolving. Now, how do we, what is the reason why somebody would choose a vendor, a supplier, or an ecosystem in India, right? Is it cost? Is it quality? Is it, what's the differentiator? I think that's what we need to really understand. And accordingly, I think the actions will follow. But if you really look at from a supply chain standpoint, we talked about composites, larger structures, but again, if I see from castings, we are very weak. We have to almost import every raw material, including, the basic raw material in aviation industry, right? So, which is not going to give us any competitive advantage. Very few, we don't have a good forging capabilities. These are really essential. And one of the biggest bottleneck is the special processes. Every component of an engine or an aircraft has so many special processes. And then Mr. Vaidya talked about the qualification, and we can't depend on, the foreign certification agencies. So we really have these bottlenecks. We must resolve those. And then I think government can play a big role in really creating that ecosystem. We need huge investment in setting up machinery, trainings, people, having those modern skills so that we can be globally competitive. So I think the Tier 3, Tier 2 vendors, they are doing their best. They have a lot of potential. They are waiting for the opportunities, and I think we need to unlock those, those potential. And then finally, I wanted to share this, that if I look at the overall supply chain growth, one of the best way to accelerate this is through joint ventures. Again, coming from defense offsets. That's a mandatory or necessity for an OEM. But if we can really learn the culture of aviation, I think one important thing is the culture, the sensitivity to safety, right, and quality are very, very important. It's unlike any other industry. So that kind of quality processes, safety culture, and then of course the technology know-how from the major players through joint ventures, I think will really propel us. And then our own indigenous investment in R&D will take us to the next step. So it's going to be a journey. It will not be a sprint, it will be a marathon.
Thanks, Uma. A quick follow-up question regarding technology development and research. GE Aviation is a pioneer in this space by all means. Dating back to the early 1900s, whether it is the development of super turbochargers or turbo superchargers, if not mistaken, development of jet engines, for example, it has been a technology leader and an innovator. Turbofans, for instance, it has a rich culture, a rich legacy of development of technology for the last 200 years. Sorry, about 100 years, more than 100 years. So coming from that perspective, what is your message? What are your thoughts on how a fertile ecosystem for development of technologies, for development of new ideas can happen in any company or in any supplier ecosystem in India? What are the lessons that we can borrow from your rich legacy?
I think it's a great question, Anand. Thanks for asking. So definitely, yeah, we have just celebrated 100 years of, GE Aviation 3 years ago. We are pretty much there right from Wright brothers inventing the first flight, and then the four, I would say, transformational propulsion systems that has been there so far. So one, you talked about turbo supercharger. Before that, there was piston engine, then second turbo supercharger, then jet engine, which got invented in 1942, and then the large turbofans that we see today, which has huge power and thrust to take long range large aircraft. Right now, I talked about already the fifth technology disruption, which is around sustainability and can we think beyond jet engine? Can we think of hybrid electric? So there are so many technologies. So the key lessons for us as a budding country, which is getting into aviation from a more technology standpoint, is now being a risk taker. I think that's a huge challenge for us. We are risk-averse society, and many of the companies, private companies, do not have the muscle, the money muscle, to take enough bets. So first thing is the culture of taking risk as an organization, as individuals, and the tolerance for failure. It's okay to fail, and take that lessons. And so that's the first thing I would say in terms of the culture. We need to be more tolerant for failures, learn from the experiences. And then maybe in aviation, I would say if you have 10 great ideas, maybe one idea would click, 9 may not work. I would say those are lessons learned, right? So it's not like every idea has to work and then we make money out of it. That's not the case, right? So it's a big shift in our thought process. Second is, I think from India's standpoint, there is a thriving startup ecosystem in all other industries. We see this in consumer, fast-moving goods and groceries and all that. We already see that startup ecosystem. Now, can we have more players in aviation? And we have realized in GE that it's impossible in today's era to just innovate everything within the company. Those days are gone for every company, particularly in aviation and then more specifically in GE. Because the technology disruption is so huge, no company has the money to really invest and invent within the company. So we must depend on collaboration, particularly with the startups and then with the academic institutes. So I talked about this public-private partnership along with government enabling that with the academia. So that has been a success mantra. And I wanted to share that I'm very proud to say that probably if you go to any institute, the research institutes like NAL or IITs, we have been in the forefront of taking that risk. So most of these institutes are not known in global era. We are known for nurturing great talent, as great engineers passing out of IITs, but we are not known for, this particular IIT is known for certain technology in the global era, competing the best of the best research institutes. But we took that bet and we made some of these IITs as the leaders in the research. I can talk about IIT Madras as one of the best institute for combustion research, and we worked with them and guided them in setting up those facilities. And then today they do cutting-edge research on hydrogen combustion, sustainability, and the future of aviation. So that's another thing. We should really look at the collaboration, engage startup ecosystem, and then third is I would say that taking really invest time in the technology trends is an important thing for us. Right, I talked about the sustainability, additive, digital. So if we invest on something where those technologies will become redundant, it's not going to pay off, right? So you need to be ahead of the curve and keep revisiting and being very agile and and move fast is another thing I can share. So being agile, be open to ideas and have that culture of innovation. And I just want to bring home this point again from our center in Bangalore. Not to really tell about GE Aviation, but I just thought it would be an example for other companies. See, we took a bet of setting up large scale R&D facility when India was not known for aviation as a core competency. GE was the first company to set up a large scale R&D center, including aviation. Today, I can say all the engines that we designed and developed in last 20 years, around 30% of the design development happened right from our center in Bangalore. And not only that, overall, globally, around 20% of the patents are from our center. Can you imagine? 20% of all the patents that we have in GE Aviation annually are from our center. And we have an engineer, Ravindra, who has 100 patents. I think about the kind of innovation we can, and all of us have learned about aviation and jet engine, including myself. When we joined GE, we had no idea, no background about aviation. So it is possible. That's my message for academia, for private companies, for government folks to reimagine the future and go with that passion and perseverance.
Thank you, Uma, for those words of inspiration, greatly needed in this today's times. We'll move to you, Mr. Vaidya, to talk about a little bit about the local startup ecosystem, as Uma mentioned, pointed out. It's very important to have a rich, thriving, vibrant local startup ecosystem, which is also a healthy indication of an industry's progress. To ask that question, to set up the context, I'm reminded of a small little anecdote that one of our speakers in the past shared with us. This is about Team Indus. This was this little startup that came out of Bangalore in 2017 or 18. And this was in response to the Google Lunar X Prize that Google had announced for a program called New Space Race. And it was a global competition that ended in 2018, which was for privately funded teams to land a robotic spacecraft on the moon. It should travel 500 meters and transmit back high definition video and images. Now, this startup that came up did not get any support from the local ecosystem. And it approached ISRO also, for instance, and other companies also in India to give it funding, to give it backing, to give it some technology support, but it did not succeed. And eventually the startup ended up working for NASA for its commercial lunar payload service contracts. So this is just a small example of there's so much interest in the local community for these newer technologies, but for the lack of institutional support, for the lack of private capital support, government capital support, what is the situation on the ground, sir? And how is it that we can support our local startup ecosystem?
I think this example what you gave is a very eye-opening example of what we saw about 3 years, 4 years back. But I think in the last 2 years, especially after the pandemic, the 2-3 decisions which has been taken by government, I mean, they have really set up a technology development fund. And any small, medium industry or a startup can get up to 10 crores of rupees in developing a specific technologies. Now, to help to identify, because it should not happen that what technology you are choosing is only for the academic interest and there is no end use. So the PSUs as well as the ordnance factories, they have published a list of more than 2,500 items which they are importing today. And they would be happy to buy that with the specifications and the price and the source from where is included in that. If somebody can match that particular specifications and the price, they will be surely buying it from the Indian industry. So we had an era a few years back, which used to be a NCNC kind of it, no cost, no commitment. From there, I think we have come to a far ahead. And today, of this 10 crores, what you are going to budget for your development of a particular product or a technology, for small and medium industries or the startups, government is ready to fund up to 90%. So what you will be actually incurring is only 1 crore in case you are not able to complete that technology and put it to the usage or service. Secondly, the government is so flexible today that if after the attempt has been made, if this technology doesn't realize into a product, still you will get 90% provided you pass on all the data what you have done or any IPs, as just now Uma said, maximum over IP. So government is helping today in writing down, because it is not only a research, but how to really put that papers correct so that you can apply it for IP. And there is a knack, there is a trick to really search those words and incorporate those words so that you will be surely seen and your IP will get protected. So there are specialists who have come up and government has developed that specialist. Now, considering these two and the opportunity which they are going to give it to the larger houses to build their own products in India, and larger houses to really become the kind of OEMs with the technology coming from abroad, rather than earlier, we used to become their partners as offset partners. Now the things have reversed. The Indian company will become a prime contractor and he will source the technologies from whosoever he feels it appropriate to make that product competitive. And they are also allowed to use these startups. So a proper mix of the enthusiasm which the startup brings it and the maturity old established organization brings it. If these two are combined now, and that is happening, I don't want to name because then I will be doing injustice on the others, but there are startups who have been linked with the larger houses and a lot of improvements are happening. We have seen what happened in the cryogenic technology. Instead of using hydrogen, now we are using even a complete the CNG for developing a cryogenic engine technology for the space, and that will be used in future for the aircraft also. And how these two companies put together are able to really disrupt the entire propulsion technology. Similarly, there is another startup which is coming up from IIT, and we are also part of that particular system. And we have come out with a proposal to ISRO that today they are using N2O4 and UDMH, that's a fuel and oxidizer. So oxidizer and fuel, what has been used, and it's practically banned all over world. It's only India who's still continuing with these two kind of fuels. Now we are come out with a completely biodegradable fuel which will be used, so that not only we are going to protect what is happening on the earth, but also in the orbits where a lot of assets are going to come in future. And this complete change is bringing, and I'm finding that whosoever I'm talking in the startup today, he doesn't have limitation of funds. They all have sufficient funds. What they are really lacking is a good manufacturing. What they are really lacking is getting these products tested and certified so that they can put it to the rest of the world. And this, I think in next 2 years, I am very, very hopeful that now the funds are available. Nobody is asking funds. If you go to any startup today, they are saying that, can you give at least 10% of your capacity for us to develop our parts, to try it out and to test them out? Because the startup is basically doing a lot of thinking. They are coming out with various ideas and designs. And if we ask them, or if we force them to get engaged into the manufacturing, I think once again, what happened today with ISRO, DRDO, that they were only developing, they were only managing the projects, they were only productionizing it. It's not possible for one organization to do all of them. R&D has to respect only R&D, the production units has to respect production. And this, the ecosystem, as we have been discussing, is evolving. The clusters, the consortiums are getting formed. Tie-ups between public-private partnerships is happening. Similarly, large houses with the startups is happening. And Uma, I think, pointed out very importantly, the academia. I think we neglected academia to only the basic research and to generate only more MTechs and PhDs, rather than having some product or kind of a research which will orient towards developing a product rather than doing the fundamental research. So this, I think, is a very, very good interface, what Uma pointed out, and we should really focus on it. Thank you.
Fascinating, sir. Thank you. Srini, your thoughts?
Yeah, I have a couple of thoughts. I want to just go from where Mr. Uma left, and he specifically pointed about the joint venture, bold joint ventures required, in terms of technical partnership between the Indian and the technology countries. And that's where it's already going on. That's a very good point, and that is going to be very, very essential for the ecosystem to develop and go to the new levels in the future. And one of that, it's already happening with whatever I just want to talk about, even the IIMPL. It's a very bold joint venture partnership between the Rolls-Royce and the HAL. And specifically to whatever he said, keeping a special process capabilities in India, which is very, very right. I mean, truly, so like it's to develop that kind of a capability in India today, with the kind of an investment and the competitiveness required, it's going to take a lot of time. But the good news is it's already happening. And IIMPL is one of the examples where it has an in-house capability for machining, special process capability with an extended forging capability available for exploring the opportunities other than the partners. So that is very much right. And thanks, that's a great point from Ishuma. And continuing from there, the startup ecosystem, whatever you are talking, Anand, and it was what Mr. Vaidya said, particularly in the space area where there is a lot of things happening today. With we have a good legacy of Vikram Sarabhai, Mr. Abdul Kalam, to Kalpana Chawla, the younger generation. Seeing their achievements, always dreamed about how to explore in that area. And today, if you see the total space global opportunity, we are there at around, if I'm not mistaken, around 3% or around 5% range in the space launch vehicles, including the rocket launching opportunities. But today the good news, today the good news is there are a lot of, at least 40 plus startups are available from India, including the technology, including new technologies like the unmanned aerial vehicles or the space communication systems or the nanotechnologies. There are a lot of these new startups which are showing interest in these areas and contributing. It's not just about thinking, and they are contributing to that. And they are trying to go for technology tie-up with, they get the technology from various parts of the world, and including our own ISROs or the DRDOs. So that is very, very encouraging. And another good news, whatever the startup funding, there are a lot of ways through which they get their funding, and there's a lot of opportunities. So funding per se, if there's a good idea, good thought, the funding is not a constraint today. So with all that, and another bold step required, to partner with the institutions like the IITs or whatever. Today, we have at least 200, if I'm not mistaken, there are at least 200. I just did a recent study on that. There are at least around 200 plus engineering colleges where the aeronautical engineering is taught all over India. At least 200 plus engineering colleges where it is taught, and they are dreaming about their future. And we love to just see how we can give opportunity to them to from their college days, and we are doing it. That's the reason I'm just trying to share that with you. I mean, we are doing that with one of those institutions to try that as a trial basis, to see how we can involve them in the digital progression of our aspiration. So it is going fine so far. I mean, when we take some bold steps without thinking only about the risks, I mean, it is going fine. I mean, we are able to prove some of the points, and and we are now trying to take it to the next level. So all these things are not, I can see the kind of encouragement that is happening to the students, and they are so much thrilled. And when they see the success, small success, it's not that we have designed a racket or something like that, but small success, small steps of success, whatever they see, it motivates the students, and they are dreaming further beyond. As Mr. Uma said, we are seeing learning the rocket and the aviation technology after joining the companies where we are today. But at least giving the opportunity to the students, to dream from the college days, it is going to take the whole industry to the next level, and as a country.
So
also.
true. So true. That's absolutely. And that's very encouraging. That's very encouraging for us to hear, for our readers, for the aspiring students. There are two questions, gentlemen. If you would like to take up any questions that you like, we have about, let's say, about 10 more minutes.
I can take Anand, and actually both are, I can share my thoughts on both. So first is, the adoption and scope of additive manufacturing to the aerospace sector. As I said, this is the next big disruption that we see, and the aerospace industry happened to be the first industry which has adopted metal additive manufacturing. Plastic additive manufacturing has been there, and like any other technological curve, it takes long years to get adopted. So additive manufacturing is no new technology, but it took a lot of time. And I can tell you, GE Aviation is the first company in aviation to really industrialize additive. I mean, we have fuel nozzles on LEAP engine, which were designed. And today, if you look at these additive parts, they are doing better than the conventional manufacturing for parts, which we typically make these fuel nozzles out of casting. So that's the kind. And what additive really presents us is an unprecedented advantage. Because we can combine many parts, like in fuel nozzle, we combine 19 parts into one single part. There is no barrier whatsoever in terms of manufacturability. If you are an engineer, design engineer, you have to think whether this part can be manufactured. So there are constraints from manufacturability, but here complexity comes free of cost. The third is additive manufacturing has far-reaching implications in repair overhaul. In terms of investment, you don't need to buy a milling machine, a drilling machine, a lathe, and so many machines. You just need one small additive, machine, and you can print. You can handle many different materials, but it has its own complexities. So we are in that curve, I would say, where the whole industry is going for adoption. I can share GE's story. For example, we started with fuel nozzle in 2016. LEAP engine got certified, got entered into service. So it's almost like 5 years. And now these parts are working so beautifully, which is giving us more and more confidence. So the second thing is we designed a whole new turboprop engine where we have more additive parts. Almost like 10% of the entire engine is made out of additive. Now, can we print a small engine completely out of additive? Which means we need to industrialize with the different materials for different types of complexities and all that. So one important consideration here is the cost economics. I'm not saying that every part is a good candidate for additive manufacturing. No, there will be few parts which will be real good candidates for additive manufacturing. From the point of the cost and the production rate, etc. The other challenge is the certification. How do we ensure each machine is different? Same machine with the same process, you print it with the different ambient conditions, you might get different part quality. So there are inherent challenges with additive manufacturing. I think with using digital analytics, we are trying to solve some of these challenges on additive. We use data to analyze and come out with the more robust production system, but it's a matter of time. So I would say the adoption is good, but I would have expected much better adoption. But I would say maybe 5 years from now, we would see a lot more penetration of additive manufacturing. So that being said, if you see any growing economies in the world, right, many countries have been investing in additive manufacturing because they know that this is the disruptive manufacturing technology. In India, we do have some state governments, we do have collaborations on additive manufacturing. So please stay tuned. We just signed setting up an additive manufacturing center of excellence with Tamil Nadu government. So that will be the first pioneering. I mean, we are going to do exactly what we have been doing in US and Europe, really taking the most modern parts and through academia, through government and private companies, we are going to industrialize these parts. Okay. Anand, you want me to continue on the second one or? take it later.
Absolutely. Yes, please.
Yeah. So what are the measures on sustainability? It's a great question. See, we know the challenge. We don't know the answer. Say for example, if you look at supply chain in aviation industry, you take raw material from some country, transport from that country to another country, then you do few operations in some country, right? You can't do all manufacturing operations. So the part manufacturing is split in many different countries, and the part travels a lot. So if you really count the emissions which are produced in the process of manufacturing, and if somebody wants to put the regulations around, it will prove that the entire aviation industry so far has been working on cost as the prime driver. So it doesn't matter, how much time it takes. It's, as long as you can plan those raw material and operations ahead, because you will save money. So cost has been the biggest driver for supply chain and manufacturing in aviation. If you turn around and say, I want to actually count how much of emissions we produce, the entire supply chain will get disrupted. Right. So as I said, now the supply chain is competing with another supply chain, which means we need to really have clusters. We need to have all the manufacturing shops together. You could be competing with another country. If I take, say, Indian private companies, they may be competing internally, but they need to also collaborate. So we must have that kind of a cluster approach so that we would be known as best in terms of cost, quality, as well as sustainability. So sustainability is still a very tough thing. Just I want to close on another thing on sustainability. We always think of, how do I, maybe I use sustainable aviation fuel, some biofuel, right? Because it's zero pollution, let's say. But in the process of manufacturing the biofuels, some of these companies which produce these biofuels are the most pollutant industries. So it doesn't really help the theme of sustainability. We are looking at the entire thing, right? We are not transferring the pollution from one place to another place, right? So we need to address this as the entire system. And if you go for sustainable aviation fuel, let's say, which is great, what happens to crops? Do we have land for food? Does it pose another big challenge? And in the process, we would incur more pollution, more threat from sustainability standpoint. So sustainability from emissions, sustainability from economics. I think both are important.
Brilliant points that you brought up, and I'm so grateful and happy. Now, for example, yesterday we were having this discussion from automotive standpoint, and this thing came up that in electric vehicles we are talking about saving of carbon footprints, but that is only downstream. What about upstream where electricity is generated? That is the biggest polluter among all the sectors. The biggest user of fossil fuels, for example. People are only seeing one part of the overall picture. I'm so glad you brought up the bigger picture scenario. Mr. Vaidya, you would like to take this question of sustainability?
Yeah, I mean, the sustainability, we see it in three parts. One is the low-hanging fruits, like what we just thought of, replacing what we use for packing or plastic or the transport, what Uma brought in, which is very easy and very quickly one can take a decision and can implement it. The second one is the medium-term kind of a thing where you are proposing to change a fuel from what I just described, from the carcinogenic fuels or the environmentally not good fuels to environmental friendly fuels like hydrogen and biodegradable like ethanol and what we are trying to use it. So that's another way of looking at it. But I think in manufacturing also we can do a lot. There are lots of chemicals, gases, solvents which we are using it today. They are highly environmental, not very good, and replacement towards this will bring in the current level only. Of course, it will require a lot of validation. That's why I'm not taking that into a low-hanging fruit, but to take it into this and I have seen in Kerala, a lot of studies have been done. They have found some special seeds, which if you really extract the oil from those seeds, and they are the best solvents. You don't require really a detergent, or you don't require a very sophisticated solvent like isopropyl alcohol and others, but you can use the extracts of those seeds from our Ayurveda. And that, if we can do it, where India has a lot of knowledge, and we have been practicing this for the medical usage, now the time has come where I think this has to be brought into the industrial usage also. That will bring in a huge sustainability. And the last, which is very, very difficult to really think. I mean, we just said that now the most of the travel, especially the air travel, is going to be for leisure. Why are we going for a leisure travel? Because we are able to see it today. The feel what we wanted to get by seeing and going to that particular location is quite well obtained through the various means what we are having today. But we are still not able to really get a feel of touch. I mean, if I really go and touch a tree or a bird or something which is not seen in my locality, but if I go to another place, I can really see that. Or the smell, the overall environment over there. It is not only what we see. I think all five senses, when we are able to transfer, and like today, I mean, very comfortably, we are able to communicate. We have no issues. We are able to see each other. We are able to discuss with each other. It is as good as I am finding that it is good as the physical meeting. But still, we are not able to touch each other. We are not able to shake hands with each other. We are not able to really smell the environment, what is going to be there. So when that will happen, I think the real sustainability will come in. The feel, touch, all the five senses, when we are going to really bring it into this kind of a new technologies, then the disruption will happen, and then we'll be able to save quite a lot. I will just take and bring to the first question which has been asked on the additive manufacturing. And I really respect the efforts which have been taken up by GE into the aviation industry, and the fuel nozzle, the example what Umar gave up. But my argument with all the designers is that now you have a better technology. So why are you asking us to just stop milling and turning and drilling and boring and do it by additive manufacturing? Now you have a better technology. Please reduce the number of components, and please also think something which you wanted to really do it, but because of the limitation of the manufacturing processes, you were not able to design. So bring something which now the 3D manufacturing can actually bring to our A's, and we'll be able to do far better. So let us turn this 3D manufacturing not to replace the current processes and do it much faster or quicker, but really add more value to our designs, and what was impossible one time can be made possible now. A combination of alloys, I mean, it was very difficult. In 3D printing, you can have part of it printed in stainless steel, part of it printed in very high strength alloys, part of it covered with copper or something for high conductivity, and the three faces will demonstrate the three characteristics which ideally you wanted. But in place of that, you use three different components. Now you have opportunity where print in one with proper barrier layers between the two alloys if they are not talking to each other, and make something unique.
Wow. So many good things coming out of this discussion. I'm really glad that this is being broadcast live and is going to be there for posterity for us to document the whole discussion. Srini, your concluding thoughts on what the other speakers said?
Yeah, two nice questions for the time, right time. I'll go to the sustainability first. I mean, my colleagues have told already, the points from a larger perspective. So I will stick to the basics. I mean, talking about sustainability, I will stick to the eliminate. Think about, whenever you are using consumption, eliminate, reduce, recycle, reuse, those kind of principles. In the interest of the speaker's larger audience, just I want to apply these simple thoughts in whatever you are doing. I mean, that itself, it's a great contribution to the sustainability for the future. So it is like, consuming more than whatever is really required. If you can eliminate that, so you are going to leave that for the future generations, for our grandchildren, great grandchildren, or like how our ancestors have left something to us. So let us think from that simple aspect. How do we eliminate waste by thinking in a different way? That's going to help the future. Having said that, we are really adapting. It is learning from each other's success. There is no real solutions available for every problem, whatever we have. And whoever takes the lead is they'll have a lot of followers. But at the same time, this is one of the area where from India, a lot of the younger generation is going to. Even the speaker from India was a part of the COP COP26, and then the way she articulated, leave a better world for us. She was kind of, trusting the industries. From our side, we'll have to definitely contribute more than what we are thinking today. So there is already, it's going to be a condition of business in the near future. That is going to come faster than before. A lot of actions are happening from the fundamental reduce, recycle, reuse concepts to the kind of, applying that to the new, adapting the new technology in terms of biodegradable oils, or how to use the, better use the cutting tools for a longer life, or how to use alternate energy instead of the thermal energy, whatever you are consuming today. So there are a lot of thoughts already coming into the pipeline, and we will have a successful solution for that. And I'm sure, like the audience, whoever is here, they will have much more thoughts on the subject. But it's an evolving area, and everybody will have an opportunity to contribute there. Coming back to the ALM, which is another close to heart subject for me. Mr. Vaidya and Mr. Uma, they have already spoken a lot on that. I agree with all their points. But the good thing about what Mr. Vaidya said, designers now can use their imagination to the best and provide a better product, a safer product to the world, to the consumers, and a cost-effective product, but a better product in terms of safety, and also in terms of using the imagination, they can provide much more futures to the consumers in a much better way. It cuts across the industry, and in aerospace, it's already working fine, and with many players adopting it, including ourselves.
Thank you, Srini. Before I close this discussion, I'm really keen to know Uma's response to what Mr. Vaidya said about additive manufacturing for our readers' sake.
Yeah, no, absolutely. No, that's exactly what additive manufacturing would provide. The complexity comes free of cost. And as I said, it's not that we have to think of how do I make the same part out of additive manufacturing. We need to reimagine. Like I said, in fuel nozzle, we combined 19 parts. In catalyst turboprop engine, we combined around 900 plus parts into 13 parts. So you can reduce the number of parts and then reimagine, make it more aerodynamic. So additive manufacturing reduce the number of parts, which means number of repairs, the failures that would happen. If you have 900 parts, you are talking about that many failures, potential failures, versus there are fewer parts. So automatically it improves safety. So when you combine so many parts, it will reduce the weight, and then we could design more aerodynamic, more fuel efficient, which means it helps on sustainability, right? So weight reduction, cost reduction, improving efficiency. So it has far-reaching implications. And then, of course, reimagining, coming out with more innovative ideas. So additive manufacturing is for the future. And in fact, it has a good linkage on sustainability. See, today, we make parts out of subtractive manufacturing. You take a big, if I take an airfoil, for example, you take such a block, 90% you machine out. So that means that much of electricity, that much of material, which is processed in a very, and consumed so much of power, energy to really make the raw material, make the forging, and then ultimately you take 90% of the material out, right? So much of, so if you really look at from sustainability standpoint, it is one great lever that we have. And then think of also the number of machines that we would employ to make a part. All those are gone, you just have one machine. So many different tools and materials and machines. So if you really see, it's one big lever that I see from sustainability as well.
Awesome. Thank you so much. Thank you so much, Umar. Thank you so much, Mr. Vaidya. Thank you so much, Sini, for this fascinating talk. Last 2 hours have been packed with insights that I personally have not seen in any forum on aerospace before. Thank you. You gentlemen have a great, great day ahead. Thank you for your participation.
Thank you.
Thank you so much, Anand.